I heard somebody say it's not just good.
Come on.
We're going! Maybe somebody was trolling.
So, first thing we're going to need is a delta x. Delta x is b minus a over, you guys know this, come on, it's b minus a over n.
And why do we need a delta
To know how, because we're breaking this up into intervals of 4 trapezoids, so we know where each endpoint is.
Right.
Hey, just so you know, you guys. You guys following? Why do we have to have a trapezoidal rule on this problem? If I asked you just to do this problem straight up, without a trapezoid rule, yeah, that's true. You're right. Trapezoids and rectangles, there's a little bit different process. My question is, couldn't we have just done what we did, not last time, but last time? What did we do last time?
U substitution.
So if we let u equal 1 plus x to the third,
Yeah. Oh.
what's du?
U is going to be,
3x squared dx. What's the problem then, you guys? You need to be able to recognize this problem. There's a
3x squared.
Do we have a 3x squared?
No.
And the issue is we can't just add a 3x squared here and then divide by 1 over 3. We can't do that.
Why not?
Okay, you can do that with integers, but not with variables, because we don't know what x equals, and x might be 0, and we'd be dividing by 0.
Wow.
Okay, do you guys see why we have to approximate this?
Yeah, I see it.
Okay, this has to be done approximately using the trapezoidal rule, or the Simpsons rule, which we're going to see here in a second.
Alright, well let's do b
We're going
minus
to do n equals 4, and delta x is b minus a over n. So it's 2 minus 0 over 4, which is 1/2.
Wait, isn't it b minus a over 2n?
Well, that's the trapezoid rule. Delta x is just b minus a over n.
Oh.
So now we need an x sub 0, x sub 1, x sub 2, x sub 3, and x sub 4. Isn't that what we did on the last? Look in your notes, you guys. Isn't that what we did on the last problem?
Yeah.
Right up here in example 2, part B, or whatever this was.
What's the equation for the trapezoid rule? I think I have it. It's just completely sloppy in your notes.
Looking at those examples, x sub 0 is the furthest left of our endpoint. We're starting from 0, so that's going to be 0. The reason we needed the delta x is we know we need to know how much to increase the interval every time we move to a new subscript. X sub 1 then is going to be 1/2. X sub 2 going to be 1. X sub 3 is 3/2, and x sub 4.
That's what the delta x is for.
Because we're just adding a half every time, right?
Right.
And x sub 4 is equal to 2.
I was so confuzzled, but
I don't know why.
Now Simpsons rule, sorry, not Simpsons rule, Trapezoid rule says the integral from 0 to 2 of this can be approximated, and now it's just up to you to remember the formula. It's not going to be provided for you. You're going to have to remember this.
Okay.
So I know the first and last don't have times 0, and those times 2.
Correct. What's the little thing that goes in front? B minus a
Over n.
over 2n multiplied by a whole bunch of stuff. It's f of x sub 0 plus 2 times f of x sub 1 plus 2 times f of x sub 2 plus ... Do all of them need a 2 coefficient except for the first one and the last one. So the last one's going to be just f of x sub 4.
If I want to write the plus 3 and not do the dot, I'm going to do that.
Sure. Yep. I'm just trying to save time because my hand got a little tired there. So we have 2 minus 0 all over 2 times n, and n is 4, so that's 8. So that's 1/4. Now, remember the function is the square root of 1 minus x to the third, and x sub 0 is 0, x sub 1 is 1/2, x sub 2 is 1, x sub 3 is 3/2, and x sub 4 is 2. So what's f of x sub 0? Square root of 1, which is 1. I know I'm moving kind of quick. You guys with me?
Yes.
Now we have 2 times whatever f of x sub 1 is. Oh, mama. Okay, so x sub 1 is 1/2. 1/2 to the third power is 1/8. 1 minus 1/8. Is it 1 or did I write the function wrong? Is it 1 plus the square root? No, it's 1 plus. I wrote it wrong. It's 1 plus. Sorry.
Makes it easier.
1 plus 1/8 is 9/8. So this is the square root of 9/8 plus 2. And now we need x sub 2. Well, this is nice. 1 cubed. 1 plus 1. That's just square root of 2. Plus. Now we need x sub 3, which is 3/2. All right, here we go, you guys. Follow with me here.
27/8
27/8
plus 1
plus 1
gives you 35/8.
So it's the square root of 35 8 plus. Now if x sub 4 is 2, 2 cubed is 8, 8 plus 1, square root of 9 is 3.
And we're just going to leave it like that.
That is your answer.
So it's 1/4 times 4 plus 2 multiplied by the square root of 9/8
Now we need to find a common
plus
denominator.
2 times the square root of 2 plus 2 times the square root of 35.
You got to distribute that 1/4.
8.
What is that the answer?
Now you would just type this into your calculator and approximate it.
Oh yeah, we don't have to do all this.
So the brackets be replaced with parentheses.
Sure.
Okay.
So you guys need to practice using your calculator to get
No, they must be
a more exact approximation.
What is the difference between brackets and parentheses?
I just use brackets here because I had parentheses here. Brackets is like a double parenthesis.
It's just like a semicolon when you have a list of things with.
Yeah, you can think about it that way.
Plus 3, plus 3, Brandon.
Oh, plus 4.
Plus 3.
Well, I added your 1 and 3 and made 4.
What do we get?
Then I do times 1/4.
3.28.
Yep.
Now, here's something you probably ought to do as
Ow,
well.
my wrist is popped super hard.
Go to y equals, you guys.
Okay. Stop, okay. Stop. It's scary. It's like that one movie, Reconstruction. Yeah, what is it even? I got 3.0 jaws going crazy.
Type in the square root of 1 plus x to the third.
Second, geometry with 1.
And then grab it. Okay, and then if you hit second and trace, you can find an integral. So I'm going to go option 7. Lower limit was 0, the upper limit was 2. So the actual area under the curve from 0 to 2 is 3.2413. You're pretty close, right?
Wait, you can't, if there's not even an equation to solve this, how does the calculator solve it?
It does that whole
It
process.
does the limit to infinity.
Oh, it doesn't limit to infinity.
Yeah. Now,
That's
yes, I'm just making you aware on your test. This answer here is going to be one of your answer choices. This answer here might be one of your answer choices. Okay? If you answer this one, that just tells you to use the calculator and you didn't know how to use this, and you won't get the answer correct.
Oh,
You guys understand what I'm saying?
Mr. Why would you do that?
You can use a calculator to help check your answers, but
This guy. I like typing up like approximate.
approximate.
with more
Like
track.
ask about calculator questions like, did you know?
Now, for those that have the time and the desire, I guess,
I have lots of time.
you can download programs off the internet for your calculator. So you've hopefully noticed on your calculator there's a little thing here that says PRGM,
Yeah,
stands for program. You can download programs off TI's website. One of those is the Trapezoidal Rule. It'll allow you to type in the function, the number of trapezoids. Okay?
They have a,
And it'll do
they have
it
a
for you.
texting program. Yeah, do they have Mario?
I don't know what games they have.
You
But,
like text answers to our button. And I like Mario. You like
so anyway,
download the text.
let's do Simpsons Rule.
Okay, Kate, what's the
Simpsons Rule. I need a new page.
Oh,
Here we go.
nope. Stuff. I almost have to just keep pressing output to type words.
Here it is.
That does suck. It really does.
Let F
So much easier.
be continuous.
We haven't learned the Simpsons Rule.
Nope, this is new.
I thought we'd been using it the whole time.
That's the Trapezoidal Rule.
Simpsons is circular rule.
Here's howdy. 1-0 fast. That's all that thing.
Here's Simpsons Rule.
Where's 0?
Ooh, n's gotta be even integer.
Yeah, B minus A,
Talk about unevenness and stuff.
3N. What was Trapezoid Rule? It was B minus A over 2N. You guys remember that?
Yeah.
Simpsons Rule is B minus A over 3N. Just try to notice the differences there. It's F
I wonder for time.
of x sub 0 plus 4 f of x sub 1
What the? Simpson just
plus 2
stole it. Time to like
f of x sub 2
Simpsons are dirty. He's like, sometimes he's like, screw over.
plus 4 f of x sub 3 plus 4f of x sub n minus 1. That's the second to last one. Plus f of x sub n. That's the last one.
So, let's say you had 5 terms. So you do 4f of x3, 4f of x4, and then just
Wait.
We'll talk about that. That's a good question.
Back to
Well, let's notice some of the differences and similarities there. First of all, the first one has a coefficient of 1. The last one has a coefficient of 1. Isn't that just like the trapezoid rule?
yeah.
Okay. In the trapezoid rule, it just went 2 to every other one was 2, right? Here, it switches from 4 to 2, from 4 to 2. The second to last one is 4. So the coefficients are 1, 4, 2, 4, 2, dot, 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 4, 1. Those are the
Does it have to be
coefficients.
4, 1, or what if it lands on 2, 1? Or does it need to be wait.
An even integer.
Okay.
oh, that's why it's gonna be even.
Yeah.
That's with the whole
What
even.
is it?
Yeah.
What is the requirement?
N has to be an even integer.
N. Okay.
And because n is even, you'll always have
That's
a
what all
4 for a second to last one and a 1 as the last one. Yeah.
We'll start way over here.
I know. Other
Was that? So, as an example, we're going to do the same problem using 4 for n, but this time we're going to use Simpsons Rule. We're just going to compare.
Is the last one just f of x n?
Yeah.
The last one's just f of x n with no coefficient. Yeah. So we're going to do the same problem. Trapezoid Rule gave us like 3.28 something, 3.28. We're going to see what Simpsons Rule does. Starts exactly the same way. We still need delta x, and it's b minus a over n, which is 2/4, or 1/2. That's delta x.
And our n is 4.
Wow.
So x sub 0 is the very furthest left of our interval, which is 0. And then delta x tells you your increase. If you increase by 1/2, then this is going to become 1/2, then 1, then 3/2, and then 2.
Wait, doesn't that make 5
Well, the Simpsons Rule actually doesn't use rectangles over trapezoids.
Oh. Yeah, x of 4 should be 2 now. Change your x of 4. It says 4 should be 2.
What's that?
Your x of 4
Oh,
should be 2.
sorry. My math was a bit off. It's 2. 3/2 plus 1/2 is 2. Not that it matters a whole great deal, but just so you are aware of what's happening here. Simpsons Rule doesn't use rectangles or trapezoids.
Assumptions.
It uses dodecahedrons.
Yes.
No. If we had some curve like this, and we're trying to figure out the area underneath the curve between two x values, x sub 0 and x sub n. Okay. This is what Simpsons Rule does. The middle of this, right about here, it would break this up and approximate using some kind of a different polynomial, if that makes sense. So from here to x1, it would approximate the area using some kind of a polynomial instead of an actual trapezoid. It's kind of hard to prove, and it's more theoretical than you really need to know, but it's not trapezoids, it's not rectangles, it's approximating each interval using a polynomial, pretty much. So it actually is a little more exact. So anyway, it's b minus a over 3n. Let's just say what's b minus a over 3n? It's 2 over 12, which is, so we have a 1/6 right there. And remember, it goes f of x0 plus 4 times f of x1 plus, so what's f of x0? It's f of 0, but f of 0 is, okay, you guys are starting to lose focus here. X0 is 0. If you plug a 0 into the function, we're going to get 1. Plus 4 times, aren't these just the same values as last time?
Yeah.
Well, so just look in your notes and tell me real quick. Square root of 9/8, and then it's 2 multiplied by square root of 2, and then it's a 4 multiplied by square root of 35 something, 8, and then what was the very last one? 3, yeah. And this one doesn't have to have a coefficient because it's the last one. Yeah. So, you guys, the difference was what you're multiplying by. It's b minus a over 3n, and the other difference are your coefficients. It goes 4, 2, 4, 2 instead of just 2, 2, 2.
Which one's more accurate?
Simpsons Rule.
And so
most of the time.
on the test, you'll want us to do it.
It'll specify
it'll
one
say
way.
which way.
I feel like the other guy just divided by 2.
So what do we get from this?
How is that even possible?
You got 3.2396.
What a weird word.
Now, if you remember the actual area, I forgot what it was. It was 3.24. The actual area was 3.24. We've got 3.239. So this Simpsons Rule got us a lot closer than, what was the trapezoid, 3.28?
Wow.
And the trapezoid was 3.28.
See if I can use the word.
So I'll just do one more here for practice. We're done with it for today. We need a. Ooh, dang it. Alright, sorry about this. It has to happen though.
These extra examples are just superfluous. I must say that this square root of paper feels very far away now.
Looking at the bounds, you know what's coming.
Yep, cosine graph.
It can be a sine or a cosine.
What does it mean?
Cotangent graph. Yeah.
These extra examples are secant square root. What's the
Square root
above what is needed or necessary? I have to agree with my sister, buddy.
Oh, you ruined us.
Oh my gosh.
Let's use, I don't know, you guys want to use Trapezoid or Simpsons, doesn't matter.
I say we use Simpsons. So is there like a better to exploit Simpsons?
Simpsons is more accurate, but you have to have an even number of intervals, and it has to be even.
So on the test.
If it's not, then you'd have to use Trapezoid Rule.
So on the test, you'll give us 4 rectangles and they say use Simpson Rule. If we use the Trapezoid Rule, that answer will be on there. Oh, that would be so
Let's
bad.
use Simpsons.
3 of the answers are actually right.
I can't do that.
Use Simpsons.
No.
Alright, so first let's find delta x.
I'm going to give you guys about 8 minutes to work on this, and then we'll go over it together. So let's don't waste time.
Oh dear.
Okay, this is the 40 on this.
So, delta x.
You don't.
What did you guys get for delta x, K?
For delta x, I got
Okay.
pi. Wait. Pi 8.
That was a good one. You don't like.
Okay, so pi 8.
I totally caught it.
So, x sub 0 is 0. X sub 1 is pi 8. X sub 2, if you add another pi 8s to pi 8s, you get pi 4.
X sub 0 was pi 8.
X to the x sub 3. Come on, you guys.
What?
Is 3 pi 8s. X sub 4
That feels like I'm in the weight room.
should be pi halves, because your lower bound is x sub 0, your upper bound should be x sub 4. You guys with me so far?
Yeah.
So now Simpsons Rule is b minus a over 3n, so that's pi over 2 divided by
12.
See, 3 times 4 is 12, so that's pi 24ths. Now the function, what was the function? The square root of
1 plus sine squared.
No! That's what I forgot to do. I got to delete all.
Okay, so guys, what's the sine of 0? Sine of 0 is 0, right? 0 squared? 0, 1 plus 0? 1, and the square root of 1 is 1. We have a 1 right there.
For the rest, use your calculator.
For most of the rest, you would use a calculator.
Besides the last one.
Okay. So we need a 4 right there. Okay. The sine squared of pi 8, I'm just going to leave that for right now as the square root of 1 plus sine squared of pi 8. The more you round early on, the further away your end result might be. Plus, now we need 2. Now guys, this is x0, this is x1, this is x2. x2 is pi 4ths. What's the sine of pi 4ths? You guys know this, the sine of pi 4ths. Square 2 over 2. Now square that.
2 for 1/2.
So it's the square root of 2 over 2 squared.
Which is
1/2.
2 over 4, which is 1/2.
It is 1/2. Okay. Now you add 1 to that,
That gives you 3/2.
and then you square root it. So it's the square root of
3/2.
3/2. Did you guys follow that?
Like the leader.
Okay. Are you guys with me here on this? Now we've got plus 4, another plus 4. This is now x sub 3, which was 3 pi 8. So I'm just going to leave that for right now as a square root of 1 plus sine squared of 3 pi 8 plus, what's the sine of pi halves?
Sine of pi halves is 1.
You guys following?
Yes.
At this last interval where pi halves, the sine of pi halves is 1. What's 1 squared?
1.
1 plus 1 is 2, so it's the square root of 2. Okay. This is what I would plug into the calculator just to avoid having to round here and round here. Otherwise, it get maybe a little off.
You do sine of pi 8 squared.
In your calculator, to type sine squared, you would do sine of pi 8 parentheses. Make sure that's in parentheses, and then you square that. Sine squared of pi 8 is the same thing as sine of pi 8 squared. That's how you would have to type this in your calculator. You guys following?
Like the leader.
Now, who got it? Did anybody get an approximate on this?
Yeah, I did, but I got it wrong.
Let's hear some of your different approximates. You got 1.85, 1.90.
Ooh, I got 1.902.
We're all getting a bunch of different stuff.
I got 1.06.
You got 2.06?
Mine's way wrong because I did pi x of 0 was pi 8.
You guys realize this is going to be multiple choice.
Testing skills.
So this is you guys. This is the best way to type it into your calculator. If you type it in like this, you're not approximating until the very end. Okay? But if you turn all of these into approximations, and then you approximate your approximation, you're going to be way up. Okay, so what'd you do? You said you typed this in? What'd you do? 1.500. Well, I don't know what that. This is just a made-up problem, so I don't know what the answer is.
You made it so much spot.
Well, it comes out of the book, but there's no answer to it.
1.9!
You got 1.9?
Yeah! I even plugged it into the calculator.
Well,
1.9.
let's see what the actual area is.
Oh my gosh, I got it spot on, man. Look, 1.9.
Square root of 1 plus sine of x. Oh, square.
And pi halves, right?
The actual area is 1.91. The actual area is 1.91. So those of you that got 1.9-ish probably.
Feels good to finally get that answer after constant typing.
Literally, how does that hurt my back to have good posture?
Oh, it kills.
Hurts your back to have good posture.
Yeah, we sat that whole period with perfect posture.
You guys need to work on your core strength.
Oh.
Do you ever do any core exercise?
Who does quarters? You guys